Archaeologists have discovered an ancient architectural wonder that could keep ice frozen in the heat of summer, centuries before the invention of electricity. That sounds nearly impossible. How could a civilization without modern technology defy the melting point of ice? Was there a lost technique we are only just rediscovering? Actually, the answer is pure engineering. What you're looking at is an ancient architectural breakthrough found in South Korea. But this isn't the famous stone freezer you might have seen in travel brochures. This is something older, grittier, and significantly more mysterious. You are looking at the oldest ice storage facility ever discovered in Korea. It was found buried deep beneath the historic Busasan-sersong fortress in Buya, and it changes everything we thought we knew about ancient cooling. But don't get it twisted. This isn't just a hole in the ground. It is a precision instrument. The exterior looks like a simple patch of earth, but this design is intentional. The layer of soil reflects direct sunlight and insulates the bedrock beneath, preventing the external heat from penetrating the vault. But before we explain exactly how this reverse oven works, let's talk about why it was built. Imagine living in the Baekje Kingdom around the 7th century. Summer in the Korean peninsula is hot and incredibly humid. Food spoils in hours, medicines degrade, and if you are a king trying to project power, nothing says, "I control the elements." Quite like serving a drink with floating ice cubes in the middle of July. For a long time, the big question for historians was, how did they do it? We know the Romans brought ice down from the mountains, but that was a race against time. The Persians had the yakshal, a giant cone structure, but the Koreans developed a completely different solution, one that was underground, discreet, and incredibly efficient. This newly discovered freezer in Buyaya wasn't just a luxury, it was a matter of national importance. The government actually established a dedicated system just to manage ice. It was that valuable. If you were a high-ranking official, receiving a block of ice from the king was the ultimate status symbol. It was better than gold because you couldn't eat gold to cool down. But storing ice is fighting a losing battle against physics. Heat always moves to cold. That is the second law of thermodynamics. To stop ice from melting, you have to stop heat from moving. And that is exactly what this bedrock bunker does. So, let's open up this ancient machine. Most people know the Seokbinggo, the famous stone ice houses with the arched roofs found in Gyeongju. But the discovery in Buyo is different. It predates those famous arches by centuries. It dates back to the Sabi period of the Baekje Kingdom, 538 to 660 AD. Instead of building a structure on top of the ground, the Baekje engineers carved this freezer directly into the decomposed granite bedrock. Imagine taking a massive spoon and scooping out a U-shaped rectangular pit, about 8 meters long and 2 meters deep, right out of the solid earth. Why bedrock? Because the earth itself is the best insulation money can't buy. Here is the physics lesson, thermal mass. We all know this. If you go into a basement on a hot day, it feels cool. The ground temperature a few meters down stays relatively constant year-round, usually around 10 to 15 degrees Celsius. By sinking the fridge into the ground, they utilized this stable, cool temperature. They didn't have to cool the air from 35 degrees down to 0. They only had to cool it from 15 down to 0. This gave them a massive head start, but they didn't just dig a hole and walk away. The excavation revealed that the walls were slanted slightly inward. This wasn't a mistake. It was to prevent the soil from collapsing, but it also helped concentrate the cold air at the bottom. Then, they did something clever with the southern wall. They reinforced it with heavy stone blocks. This wasn't just for structural support, it was a thermal hack. The scientists at the National Research Institute of Cultural Heritage believe this stone wall was designed to control the interior volume. It acted as a thermal buffer, absorbing any stray heat that managed to penetrate the entrance. Think of it like a cooler. You know how a good cooler has thick walls? The earth was the thick wall, and the stone lining was the plastic shell. It's like putting a smaller cooler inside a bigger cooler. But heat isn't the only enemy. The biggest threat to an ice house is actually water. Wait, isn't ice made of water? Yes. But liquid water is a heat conductor. If the ice at the bottom melts and forms a puddle, that puddle will eat away at the rest of the ice block faster than the air will. So, how did the ancient Baekje engineers solve this? They messed with the floor. If you look at the center of the floor in this bedrock pit, there's a specifically designed drainage channel. It's simple, but brilliant. The floor is built on a precise slant. This incline ensures that as soon as a drop of water forms, whether from melting ice or rain, it flows away immediately. It travels down the slope to a dedicated drain in the floor, which channels the water out of the bunker entirely and away from the fortress. This keeps the remaining ice bone dry. Dry ice lasts significantly longer than wet ice. But the engineering didn't stop at the stone. They also used bioengineering. You can't just stack ice blocks against a dirt wall. Dirt conducts heat, even if it's slow. So, the builders created an insulation sandwich. Based on the soil analysis, archaeologists believe they used specific organic materials, straw, rice husks, and reed mats. When they stacked the ice, they didn't just pile it up. They placed layers of straw between the layers of ice. Straw is full of tiny air pockets. Air is a terrible conductor of heat, which makes it a great insulator. This is the same principle behind your double-paned windows or a modern styrofoam cooler. By separating the ice blocks with straw, they prevented them from fusing together into one giant lump, and it created thousands of tiny thermal barriers. But here is where this discovery gets really mysterious. It wasn't just about science. It was about magic. Hidden underneath this freezer, archaeologists found something that gave them goosebumps. It's called a jujingu. A jujingu is a ritual jar buried before construction begins, basically a spiritual insurance policy. It was an offering to the land spirits, asking for permission to dig and for protection over the building. The ancient Koreans were brilliant engineers, but they were also deeply superstitious. They knew that defying nature, keeping ice in summer, was risky business. It felt like cheating the gods. So they hedged their bets. They used physics to keep the heat out, and they used the jujingu to keep the bad luck out. And inside this jar, they found 5 ancient Chinese wuju coins. This is a huge clue. It tells us 2 very important things. First, it helps us date the structure perfectly. These coins were used during a specific window of time, confirming the facility was built during the Sabi period of the Baekje Kingdom. Second, it tells us that this ice wasn't just a local luxury. It was part of a massive international trade network. The Baekje Kingdom was rich, powerful, and connected to the dynasties of China. To bury foreign currency under your fridge proves that storing ice was a project of immense national importance. You don't bury your loose change under a garden shed. You bury valuable currency under a royal treasury. So, you have the fridge. Now, you need the ice. This wasn't a matter of filling up an ice tray. This was a military-grade operation. In the dead of winter, usually in January, teams of workers would go out to the frozen Jumgang River, which flows near the fortress. They had to cut massive blocks of river ice. These blocks could weigh hundreds of pounds. They had to be transported from the river, up the hill to the Buso Sansong fortress, and into the pit without cracking. Once they got the ice to the bunker, the packing process began. It was like a game of high-stakes Tetris. The blocks had to be packed tightly to minimize air gaps, but separated enough by the straw to maintain insulation. They would fill the pit to the brim. Then, they would seal the roof with wood, clay, and soil to make it look like just another part of the hill. And then, they waited. Spring would come. The flowers would bloom. The temperature would rise. Outside, it might be 20 degrees Celsius. Inside, it was still freezing. Summer would hit. The humidity would spike. It would be 30, maybe 35 degrees Celsius outside. But inside that bedrock vault, the ice was still there. It is estimated that with this system, they could keep ice for roughly 6 to 8 months. That is enough to get you from the winter freeze all the way through the hottest days of August. Now, who actually got to use this ice? In ancient Korea, ice was a highly controlled commodity, treated with the same security as gold. The government kept detailed records of every block stored and dispensed, as it wasn't just a cooling agent, but a form of currency. Its distribution followed a strict social hierarchy. The royal family had the highest priority, using ice not just for refreshment, but as a symbol of power. Serving chilled dishes during summer was a way to display dominance, as if controlling the seasons themselves. High-ranking officials, such as generals and ministers, also received ice as part of their compensation. Receiving an ice block from the king was a prestigious honor, setting the elite apart from the common people. The government also allocated ice for the sick and elderly, who used it to treat fevers or heat stroke. In a time before modern medicine, a block of ice could be a lifesaver. Ice had spiritual significance too. It was essential in memorial services, keeping offerings like meat and fruit fresh for ancestor rituals. In the heat of summer, Ice was crucial for ensuring that these offerings remained intact and respectful. Because ice was so vital to both the state and the spirit, the job of managing it was high stakes. The government appointed specific ice administrators whose entire career depended on keeping things frozen, and there were severe punishments if they failed. If the storage wasn't maintained properly, or if the ice melted too early in the season due to negligence, the officials in charge could be fired, exiled, or worse. Imagine losing your livelihood, and maybe your head, just because a puddle formed on the floor. But where there is value, there is almost always corruption. This system eventually created what historians call ice tyranny. Because the supply was limited and the demand was infinite, some corrupt officials realized they were sitting on a gold mine. There are historical accounts of administrators hoarding the ice, claiming it had melted, and then selling it on the black market for exorbitant prices. They would squeeze the common people, forcing them to pay a fortune just to keep their fish fresh or their sick relatives cool. It turns out that controlling the temperature wasn't just about engineering, it was a way of controlling people. And in the heat of summer, the man with the ice was the true king. It is important to note that the Koreans weren't the only ones doing this, but their method was unique. The Persians built the yatchal, which were these massive, above-ground conical domes. They worked by evaporative cooling. They were brilliant, but they were huge, visible landmarks. The Korean method was different because it relied on the subterranean thermal mass. By burying it, they used the earth itself as an insulator. This gave them a lower profile, useful for a fortress that might be under siege, and a more stable temperature curve. This subterranean approach is actually more similar to a modern root cellar but turbocharged for freezing temperatures. It shows a divergence in engineering thought. One culture built up to catch the wind, the other dug down to catch the Earth's cold. What is truly wild is that scientists have simulated these ancient structures using modern computer modeling. They wanted to see if the airflow and drainage theories held up. And guess what? They did. The simulation showed that the specific dimensions of the BIO pit created exactly the right conditions to minimize heat transfer. It wasn't magic. It wasn't luck. It was fluid dynamics and geology. They understood that the shape of the room dictated the flow of the air. They understood that material choice dictated the flow of heat. Now you can see why this machine makes some people curious about the future. We live in a world that is dependent on the electrical grid. If the power goes out, our food spoils in days. We are incredibly vulnerable. The Baekie ice storage represents a form of passive technology. It works whether the grid is up or down. It works whether there is fuel or not. Some architects are now looking at these ancient designs to build passive houses, homes that cool themselves without air conditioning. By using the same principles, thermal mass, ventilation, and orientation, we can drastically reduce our carbon footprint. Imagine a modern skyscraper that uses a bedrock cooling system to cool its atrium, or a food storage warehouse that uses half the electricity because it's built halfway underground with granite lining. The solutions to our future climate crisis might just be hidden in our past. The story of the BI ice storage has a bittersweet ending. The Baekie kingdom eventually fell to the allied forces of Silla and Tang China in 600 CE AD. The Buso Sanxiansong fortress, where this freezer was found, was the site of the kingdom's last stand. The wooden roof of the ice storage likely burned down or rotted away centuries ago. The ice melted for the last time over 1,000 years ago. The kingdom vanished. But the pit remained. The drainage system remained. The stones remained. And deep underground, the Seokbinggo jar with its 5 coins waited patiently for modern archaeologists to find it. The Seokbinggo and the earlier Buyeo storage are reminders that primitive does not mean stupid. These people didn't have Wikipedia. They didn't have calculators. They figured this out through observation, trial and error, and a deep connection to the natural world. They turned the seasons to their advantage. They took the brutal cold of winter and saved it like a battery to release it in the summer. So, the next time you grab a cold drink from your fridge, take a second to appreciate how easy you have it. You didn't have to cut a block of ice from a river. You didn't have to carve a pit into bedrock. You just had to plug it in.